They'll be available for viewing on the H.S.A website and also on the webpage of the Construction Industry Federation. So I guess before we begin, I just want to acknowledge that it's currently European Week for Safety and Health at Work, and the focus of that is on the prevention of musculoskeletal disorders under the theme of healthy workplaces lighten the load. So it's very apt that we're running this webinar today. It's also Construction Safety Week as well, and the theme for the Wednesday Construction Safety Week is occupational health in construction. So a lot of materials on the H.S.A website around this very topic, and similarly that has been reflected on the webpage of Construction Safety Week also. So I might just go and introduce at first the agenda, and then I'll introduce the first speaker. So this is a list of the speakers for today. So our first person will be Frank Power from the Health and Safety Authority. Will be followed by Leonard O'Sullivan of the Irish Human Factors and Ergonomics Society. Thereafter followed by Emma Hines of J.J. Rattigan, and thereafter followed by Ethan Layden of Layden Consulting and Videos. We will have an opportunity for questions, so as I say, if you want to type in your questions, it's the Q&A at the very bottom right of your screen. So without further ado, I will introduce the first speaker, who is Frank Power. So Frank has worked with the H.S.A, the Health and Safety Authority, as an inspector, and since joining the authority, he's been involved in addressing ergonomic and manual handling, which is at a strategic and workplace level, and has acted as an expert witness in the courts. So his main work includes developing regulations and guidance, completion of regulatory inspections to address ergonomic risk assessments, he represents the H.S.A on NSAI, EU, and the National Disability Authority work group. So with that, I'll hand over to Frank.
Thank you very much, John, for that introduction, and thank you very much to everybody for attending this webinar today, the third and final webinar that the Health and Safety Authority is hosting in conjunction with the Construction Industry Federation. My presentation this morning, I'm going to talk about managing ergonomic risk in the workplace. So Leonard, maybe, or you, would you mind putting up my presentation there? So at this point. So when I talk about ergonomic risk and managing ergonomic risk in the workplace, I'm really talking about manual handling work activities in a construction setting in this regard, and looking at the ergonomic risk factors and quantifying those risk factors so that we can establish whether or not there are potential issues that have to be addressed. In terms of the presentation, there's different aspects I will cover today. I'll talk briefly about why we need to manage ergonomic risk in the workplace setting. I'll then speak about some of the strategies and interventions that the Health and Safety Authority has embarked on over the last 3 to 4 years to promote a bigger focus on addressing health risks in workplace settings, and particularly in construction sector. And then I'll just introduce I suppose, the risk assessment tools that we're going to be talking about here today. So Hugh, could you maybe put up my presentation now so that I can move on the slides? Hugh? And just
Frank, it's up.
Okay. Oh yeah. Okay. So it's ergonomic risk in the workplace. So why do we need to manage ergonomic risk in the workplace? There are a number of aspects, which I won't go into in detail here today, but first and foremost, we have legal duties under legislation, health and safety legislation. We also primarily need to manage these ergonomic risks to protect the health of workers in the workplace setting. And these ergonomic risks, primarily we're talking about things like excessive force, lifting very heavy loads, pushing and pulling heavy loads, carrying heavy loads. We're talking about risk factors such as sustained awkward posture. We're also talking about high repetitive work activities. We're talking about environmental factors in the workplace setting which will cause a difficulty in trying to manage loads. For example, poor quality handles on loads that have to be handled, poor quality floors. and housekeeping issues. So these are the kind of things that we need to address in respect of manual handling in construction so that we can protect our workers. Also, we want to encourage the development of innovative engineering or organizational solutions to address these risks. And we're very much focusing on the need to encourage development of solutions as early as we can in a project. So at the design stage, particularly in the design risk assessment, we would like to see more focus on addressing these health risks so that these risk assessment tools that we're going to speak about here today will be embraced and used and applied at that very stage, apart from the need to look at the issues on site. So what are we talking about in terms of managing ergonomic risk? There's a number of factors. The most obvious thing, like any management system, whether it's health and safety, whether it's quality management, you need management commitment. You need management to recognize that health risks, such as health risks related to musculoskeletal health, are risk factors and issues that need to be addressed and addressed effectively and in a very coherent way. So we need, for those responsible for purchasing equipment, designing workplaces, specifying load weight specifications for products that are going to be used in a construction setting, those who are responsible for deciding the method of work that's going to be used, and if that method of work is going to incorporate significant manual handling, that they think about that and to think about the consequences of that system of work on those that may have to do that work. We need to take steps to understand the nature of work carried out in the workplace. So what we're talking about there is, for example, you know, at the construction stage, even for the project supervisor construction stage, to think about, you know, the range of subcontractors that are going to be on site, the range of methods or installations that are going to be involved in the construction project, to think about the range of loads that are going to be brought on site in terms of, you know, the weight specification, you know, and to think about how these parts are going to be installed on site and the potential manual handling risks in putting those parts in place. So, and at the design stage as well, you know, understanding the nature of work, I think it's very critical. I think there's very good merit in these risk assessment tools that we're talking about here today, like the MAC tool, the RAP tool, that these risk assessment tools should be available for designers so that they can see and have an appreciation of what the ergonomic risk will be if they decide to go down the route of specifying a certain system of work or a certain load weight specification. We need for competencies to be developed so that ergonomic risks can be recognized and also be managed, and that these risk assessment tools can be used more effectively. And this is, I suppose, these webinars are part of that process of developing competencies. I know there are courses or training companies that provide training, more specific training on these risk assessment tools, and I think there's merit in people who are, you know, involved in a health and safety role, whether it's at design stage or construction stage, to learn more about these tools apart from what they learn here today. It also requires developing innovative engineering or organizational interventions to manage ergonomic risk. Now, we're going to have an example of that here today with Emmett Hines from J.J. Rattigan, who's going to speak about a case study in their organization that we in the Health and Safety Authority were involved in, and I'll let him talk about that later. But it gives an example of the kind of engineering solutions that we need to be considering and challenging to be developed in construction. The importance of communication and consultation with people that work at all stages of the process, from design stage right through to construction. Implementing the appropriate changes in work practices, and this incorporates again the importance of the method statement. The method statement illustrates the way activity is going to be carried out, particularly from a manual handling perspective. If a decision is taken to incorporate a new organizational measure or a new piece of equipment to handle loads, that there's a very simple step-by-step process or method statement which explains how that's going to be done, so that there's no innuendos, there's no misunderstanding in terms of how the actual method of work is going to be carried out. And then the important thing is, following on from that then, is if such method statements are developed, that relevant training and development is provided to those that will have to install the product or the load on site. So I talked earlier about the legal context. We have the three main pieces of legislation now the 2005 Safety, Health and Welfare at Work Act. There's a number of duties in there for employers, and also there's duties in there for manufacturers and suppliers, which is very relevant in respect of the types of loads that are used on site. The hierarchy of controls in the Act talks about avoidance. Avoid risk is the highest level of prevention, and that's really what we need to do in terms of addressing manual handling risks in construction sites. Is we need to push up the burden of responsibility in terms of avoiding and preventing or reducing these risks as much as possible, and not to just be depending on training, because training, manual handling training is certainly an intervention, but it is not an effective intervention if there's inherent risk in relation to the work activities that are going to be carried out. So we need to look at the whole spectrum. Manual handling of loads regulation, again, in that regulation, it talks about avoidance of risk, identifying what significant risk is. We're not saying that all manual handling work activities in a construction site are significant risk. The risk assessment tools today will give us a better understanding of what is a risky manual handling task and what's not. But the manual handling load regulation talks about carrying out risk assessment to identify what the significant risks are, and then when we know that, to put appropriate measures in place to avoid or reduce those risks. The split screen regulation is not related to what we're talking about today, but there's a lot of reference to that in relation to what we do with remote working. So that's the kind of legal context in terms of why we need to manage these risks. In the legislation with respect to manual handling risks, it talks about risk management, it talks about avoidance of risk, prevention of risk to health at work, adapting work to the individual, evaluating unavoidable risks, using appropriate means to avoid or reduce risk. So that's why we've gone down the road of this risk management approach. So this example here is, while accepting it's not a construction example, and you'll get examples of construction case studies very soon, but it's really the template I'm trying to illustrate here, the systems approach in terms of recognizing and identifying what are potential manual handling risks in a construction setting. So, like if a designer is going to be specifying a particular type of product to be installed, or if a project supervisor construction stage recognizes that there's a potential manual handling issue with installing a particular type of product on site, whether it's glazing, whether it's plasterboard, whether it's curbing, whatever. There's a number of stages that they need to think about, simple steps. First of all, collecting information about the task description. What's actually going to happen? What is the intended methods of installing loads on site? And very simply, that really means to write down very simply what are the steps involved. You move product from A to B, you move it up onto the loading bay, you move it from the loading bay to the face of a building. That kind of detail, very simple information. Then collecting the technical information around what the activity is going to involve. So this is information, basic information like the load weight specification. I've been involved in a number of inspections on construction sites over the last 2 to 3 years, and this is something I think that can be improved, is information being readily available on what the load weight specifications are for products or loads being used on site. So simple things like, for example, what are the weights of loads that are being installed on site? What are the dimensional sizes of loads that are being developed on site? So this kind of information is important, as well as maybe taking video footage or pictures of the layout of the area, the kind of activities, postures that will be required, that may be required if you do not change the system of work. So they're the first 2 steps. And then the third step then really is where you're managing and quantifying the ergonomic risk. Now, this is this scoring sheet here. People may not be familiar with it, but you will be after this webinar today, because this is a score sheet from the MAC tool. And in this score sheet, there are a number of risk factors on the left-hand side. You've got load weight, frequency, you've got hand distance from the lower back, vertical lift region, trunk twist, postural constraints, grip on the load, floor surface. These are all inputs that can create a problem, or risk factors that can create a problem with a manual handling activity. And then you have a color scoring system of P for purple, red for red, G for green, amber. And P means a very high level of risk. And how you determine that is by referencing the MAC tool scoring chart. But you can only use this, you can only score this task if you have collected the information up front in terms of the task description and the technical information about the job, but also by consulting with those that are doing the job. And this allows you to be able to determine where the highest risks are. So you can see from this example here, there's a very high risk in terms of the load, weight, and specification. Because that is a high risk, because if you look at the product that's been installed here, in this case, it ranges from 20 to 130 kg in terms of weight. So 130 kg lifted by one person is a very, very high risk. So after you've done the scoring, then you have to come up with a solution. So this example here, while it's not a construction example, it gives you an example of what can be done to eliminate or avoid risk. So this is simple intervention, which was identified by the individual in the picture. There's a company called Crane Engineering in Shannon in County Clare. They came up with this very innovative solution to avoid the manual handling of this product, which has to go into a machine. So the solution has addressed the significant risks. And what you could do if you want to review the effectiveness of that solution, you could score the new work activity as it is there. And what you'll find is that all the risk factors will have reduced to green in terms of level of risk. And that's the way you know you've addressed the risk factors effectively. So, you know, you're going to learn more about these risk assessment tools, and you're going to learn more about the case study examples in construction from Emmett and Ita later on. But just very briefly before I wrap up, I just want to give you an understanding of where we're coming from in the Health and Safety Authority on strategies to address health risks in construction and other sectors. In our strategy, you know, we talk about increasing the knowledge and understanding of occupational health risks, such as musculoskeletal injury and illnesses, raising awareness of the value of controlling occupational health risks and promoting positive health and well-being, and ensuring legal compliance through proportional enforcement. These are just some of the examples of the objectives in our strategy. So this kind of focuses our attention on what we need to do so that we get more recognition of the need to address these risk factors and risk areas in construction settings. So there's a number of interventions that we've been involved in. First and foremost, over the last 5 years, we've developed inspector competency in addressing ergonomic risk during inspection. So what we've done is we've contracted the Health and Safety Executive or Health and Safety Laboratory, as they used to be called, in the UK to come and train our inspectors on site in Dublin over the last number of years on the use of the risk assessment tools, so they can understand how these risk assessment tools operate. So that has a lot of benefits, because first and foremost, it helps the inspector recognize what's the risk, what's not a risk, but it also helps them to think about the kind of questions that they can ask in an inspection setting, so that they can get the kind of information they need in terms of whether or not ergonomic risks are being managed effectively. So to supplement that, then, it's all very well we train our inspectors. We also need to get the message out there to stakeholders in terms of what we're talking about here. So since 2017, 18 and 19, we had risk assessment workshops around the country where people had the opportunity to understand more about the MAC tool, the RAP tool, and the ARC tool. And these were very, I suppose, very practical workshops, because people had the chance to ask questions, get involved, pose challenges in terms of what they faced in their workplaces. So there's a lot of interaction. We've had to go to webinar for this year, but you know, I think you'll still get a lot of opportunity in the workshop webinar today to ask any questions and to get an understanding from the practical case studies and exercises that Ita does to get a better understanding of how these risk assessment tools work. So look, if we have over nearly 100 people online today, we had 220 at the first webinar, and we had about 60 at last week's webinar. So there is a demand and there is a hunger for this kind of information, and we will continue to provide further information and webinars in this regard. So apart from the workshops, apart from our inspector training, we also are constantly developing new guidance. These are just some of the guidance documents on our website. You know, the middle one there, Managing Ergonomic Risk in the Workplace, this was developed last year, and this was developed last year to supplement the work we're doing in terms of promoting the use of the risk assessment tools. So within that guidance document, which I think you should, you would have got a link on the events page when you registered for this event, but it is available on our website to download. It's a very useful piece of guidance, because in that guidance, it explains what we're talking about in terms of the 5-step risk assessment process. it's not that difficult to use that template. And if you just read through the descriptors for each stage of that risk assessment process, it will give you a better understanding of what we're talking about and what we're trying to do here. The guidance there on the right, the ergonomic good practice in the Irish workplace, that's another useful reference in terms of giving you an idea of what kind of solutions different companies have developed. So apart from that, then we've also published in the last couple of weeks good practice case studies. Here's a couple of examples. The first one is Organic Lens Manufacturing, which was a company that had developed solutions around maintenance activities in a manufacturing setting. And maintenance is a big part of construction projects after they're finished in terms of trying to maintain a building project after it's complete. So there's some learnings in there as well in terms of what kind of solutions you can consider. And then we have the case study, which is going to be spoken about this morning by Emmett, which was with J.J. Raskin Construction. So we have 5 of these case studies on our website at the moment, from construction, manufacturing, and the healthcare sector, as well as the education sector, to give examples, practical examples of solutions, innovative solutions that have been put in place to address ergonomic risk. So then, finally, then we're involved in strategies in specific sectors in construction and healthcare. In the construction sector, we're looking at working at high traffic management on site, occupational health with respect to respiratory, dust and manual handling risk management, and also we're engaging with duty holders around these hazards. That work will continue into 2021. So I suppose just to finish off then, I spoke earlier about these sectors, getting more appreciation of what ergonomic risks are so that you can ask the right type of questions. So these are just a range. This is not an exhaustive list, but there's some of the questions that, inspectors may ask, or even you yourselves can ask, even at design stage or construction stage. What type of manual handling activities are planned to be carried out on a construction project? Where are these loads being handled and what are the steps involved in moving a load? Do we have information on the range of contractors working on site and whether or not they're going to be engaged in manual handling activities on site, and what types of loads are they going to be bringing on site? Have you information on the load weight specifications of loads? Can you provide documented evidence that ergonomic risk factors are being managed? So, for example, have you examples of score sheets for MAC tool, RAP tool? Because that's kind of, I suppose, the level of detail that we're looking for in the future in risk assessments for addressing health risks in construction. That's what we want to see. That's the future in terms of what we want to see. We also want to see evidence that ergonomic risks are being managed by using appropriate mechanical equipment or improved ways of doing the job. So these are just some of the examples of the questions that that you could pose to yourself in terms of risk management. So then, I suppose, just to conclude, then I just urge you to take a step back when you finish this webinar today. Don't put the risk assessment tools away. Try them out. Start to use them. Maybe plan for next week or the next couple of weeks to think about the range of tasks that are happening on your construction project and maybe how we could apply these risk assessment tools. Don't be afraid to try them out. Look at your activities in your workplace. Don't be afraid to refer to our website and guidance documents that are available. So I hope you enjoy the webinar. And finally, I suppose in the situation we're in with COVID, heading into level 5, I know construction is going to remain open during level 5. I just want you, most importantly, I suppose, to stay healthy and look after yourselves. So with that, I'll hand back to John. Thank you very much.
Thank you, Frank. We appreciate just a thorough introduction to eating disorders and ergonomics. And just to mention, we mentioned about European Safety Week this week. So in a report published last year, H.S.A, which is the European Agency for Safety and Health, they reported that roughly 3 of every 5 workers in the European Union suffered or reported musculoskeletal disorders. So obviously it's a topic of high concern and demands attention. As Frank mentioned, it's important to recognise the significant risks associated with manual handling. At this point, I'd like to remind people that if they haven't had an opportunity to download the MAC tool, then you can download it on the H.S.A website. If you go to H.S.A webinars, it's available there. It's also available from H.S.A UK, and you can download there. It will certainly be a benefit for this afternoon's workshop or with Eva. So just moving on to our next speaker. So we have Dr. Leonard Sullivan. So Leonard is a senior lecturer in human factors and ergonomics in the School of Departments at the University of Limerick. He lectures in ergonomics and human factors to engineers and product designers. He's also secretary and past chairman on the Irish Ergonomic Society and a member of several international expert groups on ergonomics.
Good morning, everyone, and welcome to our webinar series in relation to risk assessment. So as chairman of the Irish Ergonomic Society, and we've had the privilege of being able to engage and collaborate with the Health and Safety Authority and various other groups, including the CIF in this instance, in supporting these initiatives around ergonomics in the workplace. I suppose just very briefly about our society. So we're the Irish professional body for the discipline of human factors and ergonomics in Ireland. And we link in to the various international groups as well. So we share our experience, but we also have international experience that we feed back into our ecosystem. That's important. A key feature of our society and our objective is to support the development and representation of the discipline. And I suppose feeding into that is supporting education and continuing professional development at various levels, which is exactly what we're doing here as part of these webinars. Our members range from quite often health and safety practitioners or workers' representatives in companies or voluntary groups. Some people may be their affiliates or associates, but we've also fully qualified ergonomists. But I would just like to make it clear that our remit is to fully support the discipline across all interests and areas of applications in Ireland. So one of the things we're very anxious to do is to help disseminate information on the latest developments. We have a monthly newsletter. If you go onto our website, which is listed at the bottom of this slide, and the little banner pops up, you can get a monthly newsletter. It's for free, and we get kept up to date about recent developments across the full spectrum of ergonomics, both nationally and internationally. We also hold our own conference and also support our own internal webinars as well as other webinars such as this to get the message out in terms of the importance of ergonomics, but also to help develop skill sets right across the spectrum of people's level of expertise in ergonomics. And that goes right down to the worker level, workers' representatives, health and safety managers, right through to fully qualified registered ergonomists. I would just mention that in terms of our membership, while we have our full registered membership for fully qualified ergonomists, we've also affiliate and associate members who can join. So I suspect the vast majority of people on this call are involved in health and safety roles. So if you have some qualifications, then quite often we find that you probably qualify to become an associate member, paying €25 per year, and it's a way of getting in our ecosystem and to be kept up to date about recent developments. It's on our website. The membership application is on our website. There's no need for certificates or anything like that. You can pick the details, your background, your roles, and we process those actually quite quickly. So I think just in terms of why we're all here today, I think one thing that remains the case is that, as we have previously heard, manual handling injuries are still highly prevalent, unfortunately, in our workplaces. Outside of fatalities, non-fatal injuries, manual handling injuries continue to account for approximately a third of all workplace accidents. And when they happen, unfortunately, they can be very severe and have a detrimental impact for many of our workers. And in many cases, workers may not ever work again when they experience really bad injuries. But we want to turn that around to a positive. And that's why we're all here today, to learn new skills to be able to help improve the safety of our workplaces, and with a specific emphasis on design. So thank you very much.
Thank you, Leonard. Just at this point, we've had a few more people join the webinar since the beginning. So just to remind people that if you have any questions, there's a Q&A function at the bottom right of your screen. So if you want to raise a question to any of the speakers today, please address the question to them. So begin with, for example, Leonard, followed by your question, and we'll try to address those at the end of the presentations. So moving on to our next speaker is Emmett Hines. So Emmett is is a company health and safety advisor for J.J. Rattigan, and he performs the role of project supervisor for construction stage coordinator on behalf of the company and on all projects undertaken by the company since the year 2000. So a wealth of knowledge and experience. Emmett has full control of implementing and auditing health and safety policies, procedures and practices within the company, and coordinates activities of some 23 safety advisors to ensure the continual improvement of safety, health and welfare within the company. Thanks, Emmett.
Morning, everyone. Thank you very much, John. So I'm just going to try and give you an example with regard to specifically to construction. And with this, it is in relation to stone cladding. So some people may be familiar with this building. It's as you come into Galway City on the old Dublin Road. We were constructing, the new Galway Garda headquarters building. And as you can see from the picture there, there's significant amount of the facade of the building has stone cladding, vertical and horizontal stone cladding. So I'm just going to go through the processes, I suppose number one, where we went wrong, and then from a H.S.A visit where we started to get things right and where we're trying to bring this to now within the company. So just in terms of the slides that I'm going through today, it'll be an introduction into what happened, the H.S.A visit, and the building in general, going on to the H.S.A visit, and I have an extract from the actual report of inspection. To go through then the weight of the stone to give you an idea of what weight was involved in the stone cladding. And then we go into the planning and the installation of the stone cladding itself and findings that we've got from changing our processes. Frank at the beginning spoke a lot about in terms of the planning and what we should have on site. And the reality of it, we didn't have information that we should have had in terms of weights, and we didn't risk assess it initially with regard to how we wanted to or how it should have been installed. It was, we accepted the method statement from the stone cladders, proceeded to go with that method statement without questioning it, and allowing manual handling to be undertaken and not looking at any other alternatives. So we got a slap on the wrist from the H.S.A, but to be fair to them, when they did visit, they worked with us to try and get the best solution for all parties and to prevent injury on the site. So when they visited the site, they wanted to look at all our practices, our method statements and that, and it wasn't up to scratch. And we had to put our hands up onto that, own up, and then move on from there to try and get the correct processes in place. And that process was done with the H.S.A. It wasn't just left to us to do it. They worked with us and discussed it. And in fact, Frank came to the job, recorded the activities that were being undertaken, and guided and advised us with regard to how we, to going forward, how we could implement other elements. So in terms of the H.S.A visit, there was elements that she described with regard to that stone cladding works of what we had to get in place for ourselves. So number one was a descriptive method statement. So it needed to have a lot of detail in it, and in fact what we agreed to go with was what we call an SOP, Safe Operating Procedures document, which actually photographed, and a lot of these photographs you're going to see in the following slides. So we broke down the process from the very beginning, photographed it, so that anybody, no matter what language that they understood or nationality that they were, it was clearly identified in a pictogram situation. And there was words as well that was given further clarity to it also. But that was the key thing. We needed to get a system, break it down and make it very prescriptive and descriptive with regard to each individual stage. and it was key that we didn't skip any stage, no matter how small it was. With regard to the stone cladding, as I said earlier on, and we'll see more examples of it on the slides coming, there was vertical and horizontal stone cladding. So there had to be different procedures for the different type of stone that was going to be installed onto the building. We needed to communicate these method statements, and again, the photographs assisted greatly with regard to this. And then the talk here, but it was a lot more than just a two-wheel buggy. So what we've noted here is really about the mechanical means that was needed with regard to the transportation, movement, lifting of the stone cladding, and we'll show you the numerous different mechanical aids that was used on this project. Just to say, with regard to this project, this is the stuff that we have implemented works for this building. It's not going to work for every building. So we, as a company, even at this moment in time, have alternative systems on alternative jobs as well. Okay. But the one thing to take from this, I suppose, when we had the H.S.A Visit, we didn't do a MAC tool. We didn't do any type of risk assessments, to be quite honest, and we put our hands up to that. We're now going forward. We use the MAC tool at a very early stage, working with the design teams and stuff like that as well, to try and make sure that we reduce, if not eliminate, the risk of manual handling on our project. Apologies, some of these red boxes have slipped a little bit, but in terms of the stone, so this is the first thing. We didn't even have the weights, and Frank highlighted this earlier on, just very simple stuff that we just did not have the information. So we had to get this information first. We had to have the information in front of us so that we could then risk assess. So we went to all the different elements of stone cladding, determined the size of it, and then to work out the weight. In terms of granite, all stone cladding elements were 60 mil thick. So that's standard for all of this granite that we were lifting and putting onto the building. But they had various different sizes, lengths by height. So the biggest one on this sheet, apologies again for the boxes, but we have 1.2 meters by 0.7 meters in depth on it. Okay, so that the width by the height, which equated to somewhere in the region of 137, and we even had a larger one there of 142 kg. So, and you'll see on the MAC tool, there's no way two men should be, even if they can lift it, it isn't safe to be doing it. And we probably all know in the practical and in the real world out there, guys have been doing this. And the reality, even if they can, they shouldn't be doing it. So 142 kgs for some of these stone panels, absolutely crazy weights that are being lifted out there on numerous different jobs. And this process has to stop. In terms of the limestone, this is 75 mil thick, so it's a further 15 mil thicker than the granite. And again, we have sizes, you know, heights greater than 0.5 meter to the width or the length of it being in excess of 1 meter. And again, we're talking 142. So anywhere from 24 kg right up to 142. But you will see that of the 12 or 13 that's on that page, 9 or so are in excess of 36. And when you look at the MAC tool for two people above 36, we're heading towards red and purple ratings within the MAC tool, which we'll see later on. So very significant, extremely dangerous weights was involved in all of these, in the majority of the stone cladding to be installed. Again, further here again, so it goes to show you the amount of different components that we had. And again, this slide is heading towards the horizontal stone cladding components as well. So the soffit, again, it's still 75 mil thick, and we're up in the region that we've even hit 101 kg for some of these, you know. So extreme weights to be lifted. So in terms of the process, there's two elements to it. One, it's getting the stone up to where we need to put it into place, and secondly is then fitting it. Okay? So we had to look at all the processes and making sure that every step was planned from the minute it comes onto site to getting up and getting in position with the onto the wall. So to go through each one, rather than going through this slide, we'll see it individually on each slide going forward. So set up, we have our stone, we know the stone that's coming in, we know the weight of all our stone, therefore we know how heavy that pallet is. We can test it with the crane or teleporter to know that the teleporter or crane is safe and has the capacity to be able to lift it. But it's critical that we actually lift it in the right manner. If this is a teleporter and it's facing into it at this way, we need to be working from the far side of this pallet when it reaches onto the loading bay. So it's important that we plan this, because there's no point opening it up and we're trying to get to the back of the pallet. So planning is critical on that, and it comes down to the planning even at this stage. So it's flown and it's brought up and it'll be put into the relevant area that we need it. We need to, like anything in terms of anyone that's doing manual handling, if you're lifting it, the roof, the environment around where you are lifting needs to be clear so that you can actually get the product and materials to where we need to get it to. So in our case, we were lifting this by crane onto scaffolding, and we'd have loading bays set up. So our trained banksman, knowing the direction of the pallet and what stones needed to be taken from it, making sure that that was to the front, brings the load and loads it on top of onto a loading bay. So just in this, I've highlighted a little section here. So when we were dropping it down, we wanted to make sure that there was going to be no failure in any way, shape or form with regard to the pallet or the stones that's on the pallet. So again, from our planning and our detailed process of looking at this system, we were adding extra planks to the back of this to make sure that there was going to be no collapse. So the next picture actually shows it a little bit clearer. So we put 3 planks there at the back of where the load would be dropped, at the mid-span or the intermediate handrail in a sense on our quick stage scaffolding. This is to ensure that when the pallet of stone is settled into position, that no stone topples off the scaffold to the floor below. So again, it's a full collective. We want to protect everybody. It's not just the stone cladding, it's anybody that could be around the scaffolding, under the scaffolding or whatever. And so these planks here just propped the stone and the pallet to make sure nothing was going to slide through handrails or anything like that. Also with it, we looked at the process and we needed to make sure that we tilted the pallet backwards. So we needed the planks at the back to make sure no stone would fall, but also we did not want the stones to be falling forward onto the operatives as they took it, if it moved in transport or whatever else. So it was tilted backwards and no fear of falling forward onto toes, legs of the personnel undertaking the work. Okay, so they were resting back. Probably something you mightn't have been thinking would have been part and parcel of this in terms of installing the stone cladding, but it was key to make sure that every step along the way was fully planned and safe. So once we had the waste material off or the timbers around the stone, we needed to get the stone to the work area. So we were, to prevent manual handling, we used trolleys. We have 2 different trolleys, which we'll see in these slides. And basically, we will have to move the stone, but we would use it on a heel and toe method. So we were never taking the operatives would never be taking the full weight of the stone. They can heel and toe it till they get to the trolley and then evenly distribute that then onto the trolley. So it'll be heeled and towed, never taking the full load and dropped onto the pallet and evenly positioned on the pallet for balance. Some of you might notice that it doesn't look like a normal scaffold here. We can't see scaffold planks, that there's plywood here. And again, that was one of the processes where we were distributing the load. Rather than having point loads down on scaffold boards, it was distributed through the plywood across all the boards that would be on our scaffolding. So again, sliding it across, heeling and towing it, and getting it centered onto our trolley. And then we would move that to the relevant section. We had loads of loading bays set up on this scaffolding. They'd never be probably travelling more than 10 or 15 metres to get to the work location for the stone. But we moved it singly, again, reducing the loads, because we saw there that 142 kg could be the weight of some of these stones, and we're travelling across scaffolding on this along with two men. So done singly, moved across, and again we distributed the load by sheets of ply on all the scaffolding on top of the scaffold planks. An alternative trolley that was used was the one that we can see in these pictures also. And again, moved and loaded onto this by heeling and towing, moving the stone panel and not taking the full weight at any time by the operators. And again, this was able to move this down to the relevant section. And when we were moving it off, we would always move it and put it onto the scaffold over a transom, which was the strongest part of the scaffold. And so it's over a node point or the transom of the scaffold. It was never left in the middle of a bay where it could potentially have an issue with the weight on the planks. So in terms of the installation, we've got our stone cladding to the location that we want to put it onto the building. We were very lucky on this project where this was a concrete frame building. So we were able to take support from the structure. And what was agreed to be put in place was these bracket systems. So they were made up, custom made for the project, for the size of the parapet, reinforced concrete wall that was at the top of this building. And basically then we would be slinging down from that structure from the very top. So we had a parapet concrete structure, made up this custom made bracket, and then we had a D-shackle with a hoist and a pulley system attached to that worked down through the cantilever bracket system that was between the scaffold, the main scaffold platform, and the building. These were all certified and made sure that they had a safe working load that was applicable with the weights that we were working. And you can actually see a blue tag there on the bracket system on the second one here that we're looking at. So that's proven it was certified to what we needed it to be. We had an alternative system as well. So with that singular bracket, we used to be able to install three stone elements without moving that bracket across. So the one directly underneath it, left and right, could be done from one positioning. Then we would move it across and do another 3 stones. Move it again, another 3 stones. So it was a little bit slower that way. We came up with a second alternative bracketry system. Again, it was bolted to the concrete structure, but it was a long steel girder. So therefore, our pulley hoist could move a longer distance at any one time. This could cover up to 10 or 15 meters without having to be moving it and repositioning it. So we had 2 different alternatives there. We had 2 different trolleys, 2 different systems for installing and moving along the pulley system. So with that, from the pulley system coming down, we purchased an Abaco lifter machine, which works on a vacuum. So this was at the bottom of the pulley or the hoist system, and it was suspended down through the cantilever board. Hopefully you can see it there, where we would remove the middle plank from the upper cantilever brackets so that the system could come down to the actual location that we needed to install. So anywhere where we had that, obviously as well, we would have had double handrails on the inside of it to not let anybody be able to get out onto that cantilever bracket when there was a gap in the cantilever bracket system. When we got down close to where we were working, we would have the operator on the lift above, and then 2 operatives at the lift where the stone cladding would be positioned. And again, it would filter down through the cantilever bracket. And that's probably our first good view of what the Abaco lifter looks like. So it's brought down, one man is working from above, two guys are working below, and they're going to be moving and adjusting the stone as is needed. So the lifter is lowered into place. We would have our stone positioned over on the plywood close to the transom. This would come down and take the weight of the stone. You can see a cross section of it there where the stone cladding fits into it, and the vacuum then holds the stone cladding for lifting. So the operatives then aren't taking any load of the cladding. They are just moving it to where they need it to be put against the wall. And then they can release it once they have it sitting on the next stone cladding that was underneath it and beside it. So with it, as part of the method statement, an appendix to the method statement was the operation manual for the Abaco lifter. Again, giving clear information and guidance and providing informal training to our operatives on the site on how to actually use this lifter. So that was an appendix of our method statement, our SOP, and communicated to all. So the Abaco took the weight of the stone, as I said there, and then the two persons guided it to where it needed to be on the wall. Using their knees, or slight adjustments with their hands or whatever they needed, they were able to position it where they needed it, and then organise the fixings of the stone cladding to the wall at that stage. After they have removed, they'll have it in position, they'll remove the Abaco lifter, and then they'll fit the fittings in place with the other operative just holding it, just keeping it in place, not taking any weight again. So we've eliminated any manual handling operations within this. So the original bracket that we saw was right at the height of the parapet. As we got closer to the height of the building, we realised, we've made a bit of a mistake, or we're not going to be able to get the last stone cladding panels in place on the facade. We need to raise this bracket system. So again, custom made, certified, so that this could facilitate the pulley or the hoist system and still be able to get the stone cladding position. So that's a third system that we had then with regard to a bracketry system, custom-made bracketry system to allow us to facilitate the mechanical lifting of the cladding. So that was part one of the installation, being the horizontal, the vertical cladding, stone cladding to the building. But there was significant horizontal stone cladding also, as we can see here, soffits at doorways and at cantilevered elements of the building also. So we had to bring in something alternative to do this. A bracketry system wouldn't work. So we brought in a double scissor lifting platform, again, which was certified to take the weight that we needed. And we saw, I think it was 101 kg, was approximately that was the heaviest stone cladding that we had on the soffit. So with the use of this, and it's not a very clear picture, apologies for that, but with insulated panels underneath the stone cladding, we would use this to lift it up into position. Once it's in position, we could adjust it slightly with some shims and stuff like that to get it to the right level. And then we would fix the bracket system as is normal with the stone cladding. But this was taking all the manual handling and lifting out of it. This held it in position while we were doing the fixing works. So numerous different mechanical means were used. And as a result of that, in terms of this building and with heeling and towing, we were able to eliminate manual handling. There was no manual handling of the stone cladding. Obviously, you can see there from where we did very little planning and coordinating, we planned everything to within an inch of its life in terms of the pallets, how they were loaded out, and there was correct stone cladding to the front, to the scaffolding, to the different bracketry systems, coordinating it with our banksmen and our different foremen and management on the job. When we implemented this alternative system with the mechanical means, we actually got improved productivity on the vertical stone from the way we were prior to the H.S.A Visit, to approximately 25% better productivity on the vertical facade stone cladding, and up to 50% on the soffit work, the horizontal stone. We saw there in the pictures that it reduced it to a 3-man team. Prior, we had 4 and 5 guys that were working on it. So as a result, we could have 3-person teams, and with the numbers that we had on the job, we could have more teams. Hence, that was helping in productivity also. And I know this is safety, but we also had improved quality and reduced damage, not chipping the stones from losing grip or something of the panel or something like that. So in fact, it assisted in safety, it assisted in program, and it assisted in quality. There was initial costs in terms of bringing in the mechanical work and mechanical machinery, but I think in terms of, you can see there the productivity, it probably would have been a cost neutral exercise with regard to that. I know there's questions later on, but hopefully that's given you an idea of one way to be able to eliminate manual handling from it. It's not going to suit every single building. Not everything's going to be reinforced concrete with a nice parapet at the top to be able to hold these bracket systems. But certainly it needs to be planned and thought out of at a very early stage. And that is something that we'll be doing. I might touch upon it maybe in the Q&As later on with regard to involving stone cladders at an early stage, and trying to, in particular, reducing the thickness of the stone back down from 75 or 60 mil to a lesser thickness and smaller sizes in terms of that is more manageable rather than 1 meter long or and half a meter high. So hopefully that has given you a better idea in terms of how we can introduce mechanical means to the construction processes. Thanks very much.
Thank you, Emma, for that. And I think you're very humble in showing the case study in terms of the lessons learned. I think it's an excellent example as to what can be done. You know, when you reassess an activity and look for a safer solution. You know, I guess what isn't measured on Emma's last slide, which is really interesting, is the savings, and what's I guess incalculable is the workers' satisfaction levels and morale. You can only presume that they're hugely appreciative of the efforts of J.J. Rattigan and Co. Because they're seeking to ensure the protection and of their well-being. So last but not least, will download Mac tool to Ita and Fred as engineer, and she's also managing director of Labour Consulting Engineers and safety training and ergonomic consultants. Ita boasts over 25 years experience in the ergonomics, engineering, safety fields, and is also involved in all areas of ergonomic design, assessment, as vision expert witness testimony, safety and training, implementation of behaviour-based safety systems, development of safety management systems, and Ita is also a part-time lecturer at Ergonomics for UCB. So, thanks, Ita.
Thank you very much, John, for that kind of embarrassing long introduction. Good afternoon, everybody. We're just in the afternoon now, so what I'm going to be covering in this part of the workshop is the practical element of using one of the HSE's assessment tools called MAC. So again, I know John mentioned it earlier on, but if you haven't had a chance to download the guidance document for the MAC tool, can I suggest that you do so now, because it will certainly assist you in participating in the workshop, because we will be using the guidance document, and you'll be getting an opportunity during this workshop to try your hand at doing an ergonomic assessment using the MAC tool. So in terms of what I'm going to cover, as I say, is I'm going to talk very briefly about the range of tools that are available from the H.S.A, and then we go through the MAC assessment and the particular guidance of using the assessment tool to assess either a lifting, a carrying, or a team handling operation. And as has been mentioned by our previous speakers, musculoskeletal disorders are the most common type of occupational ill health, and a lot can be done to prevent them. Quite often, measures to reduce the risk of musculoskeletal disorders are simple and cost-effective to implement. However, we also have to recognise that an early reporting system of symptoms and proper treatment and suitable rehabilitation are also critical in relation to managing musculoskeletal health in the workplace. So, in terms of the H.S.A tools, the Health and Safety Executive in the UK have developed these 3 assessment tools. It's based on, they're all evidence-based, so they are very good, accurate tools for doing an assessment of manual handling, pushing and pulling, and repetitive tasks. So the suite of tools are MAC, MAC. MAC stands for Manual Assessment Charts. So that's the guidance document that we use for manual handling assessments. Then, if a task involves pushing and pulling, we use the RAP tool, or RAPP, which stands for Risk Assessment of Pushing and Pulling. And if an activity involves repetitive tasks involving the upper limbs, well, then we would use the ART tool, and ART stands for Assessment of Repetitive Tasks. And within the construction industry, we would have that in relation to a lot of the trades, plastering being one example there. Now, the tools have been developed by the Health and Safety Executive in the UK, and they have obviously, as Frank from the Health and Safety Authority has mentioned there, they've been rubber stamped basically by the H.S.A here in Ireland. And the publication that Frank referenced, the Risk Assessment for Managing Ergonomic Risks publication, which was published in November last year, that provides some examples or worked examples of using these tools. So it's also a good publication. It's a free download from the H.S.A website to give you an indication of how these tools can be used. So today we're going to focus on the MAC assessment side of things and the manual assessment charts. And in terms of MAC, what it does is it helps us to assess the most common risk factors associated with manual handling. It's not appropriate for all manual handling tasks. For example, it's not appropriate for pushing and pulling. If it's a pushing and pulling task in your workplace, well then the RAP tool would be more suitable, and it's not suitable for patient handling. Or indeed upper limb disorders, then you would use the ART tool. So the MAC tool has 3 individual guidance or tools that you can use. You use one for lifting, one for carrying, and one for team handling. And at this stage, this is the, hopefully all attendees have downloaded a copy of this. So this is the free download from the H.S.A's website, and there's a link to that website also if you want to share this with your colleagues via the Health and Safety Authority's website, hsa.ie. So that's the free download. So that's the document I'm going to be referring to today. However, there is a more expensive version. There's a booklet version that you can purchase from the Health and Safety Executive. So the page numberings are slightly different. So today I'm going to be referencing the free download one. So I've done it on the cheap. So firstly, what I want to do is to talk you through the different guidance. So as you open or you scroll through the guidance document, you'll see the banner at the top of each page. So you have a blue banner, and the blue banner is the guidance document that you use when you're assessing a lifting task. As you go through, the banner after, I think, 9 pages or so, goes to red, And the guidance tool that we use when we're doing a carrying assessment is the red bannered guidance document. And then we go to dark green, which we then look to use that guidance section for team handling operations. And it's very important that you use the right guidance for each type of manual handling, because the scoring is slightly different for each. So in terms of the use of the MAC tool, for a majority of manual handling activities, it will be a suitable and sufficient risk assessment. However, there are some situations where you may need to do more than the MAC tool, or there are certain conditions where you may need to do more than the MAC tool. And this is, again, in your, at the back page of that guidance document, on page 19 of 20. On page 19 of 20, you have your score sheet. And one element of the score sheet is to ascertain if you need to do a full risk assessment or do more than MAC. And you need to do a full risk assessment if, for example, just zoom in here, if there's lifting or lowering more than 12 lifts per minute, if there's a handling activity while seated, if it's a male carrying 5 kilograms or a female handling 3 kilograms, if there's particular individuals in your workplace who might be at a higher risk, involving, say, for example, pregnant women, your young workers, or somebody who may have a predisposition. And also if there are a large vertical movement or sudden movement, a risk of movement of the load, or the load might be unstable or might have sharp edges. So if any of those apply, you can certainly use the MAC as the basis of your assessment, but you need to do more than just the MAC tool. You need to look at those other particular risk factors. Now, at this juncture, what I'd like to do is just call out there that you see there's a reference to Schedule 1 of the Manual Handling Operations Regulations. Now, of course, that's a reference to the UK legislation. In Ireland, of course, the manual handling falls under the General Application Regulations. So what you will see in two sections of the guidance document, there's specific reference to the UK legislation. However, we have the equivalent in Ireland. The actual guidance is protected by Crown copyright. So the H.S.A, although have rubber stamping this and have trained their inspectors on this and would like to see these tools used in Irish workplaces, there will still be those two references, but we will associate it with the Irish equivalent in terms of legislation. So moving on. One other thing that we do need to consider when we're doing manual handling assessments is the risk associated with psychosocial factors. And psychosocial factors include things like high workloads or tight deadlines or lack of control over the work. Where these exist in a workplace, they can increase the risk of musculoskeletal ill health. However, we don't rate them when we're doing a manual handling assessment. If as an assessor you become aware of their existence in the workplace, we document them, we capture them on our score sheet, and we then leave it up to the relevant competent individuals either within your organization or externally to deal with those psychosocial factors. But we do need to capture them because they do have an impact on musculoskeletal health. So how do we complete a MAC assessment? Well, the first thing to do is to identify what tasks need to be assessed. So the suggestion is always to choose the ones that you know are hard work or there have been complaints about. And if you're not really sure, although I would suggest that on most construction sites, you'd all be able to list at the top of your head the top 5 manual handling activities that would be considered hard work. However, if you're not sure, you've addressed the top 5 and now you want to know and identify what do I do next or what task do I assess next. A very good idea is to literally just put on an ergonomic hat and walk the site or walk your workplace and ask questions such as, how does that get from there to there? How does that delivery move, how does that move from the goods inwards area to another area? And that will, from that type of questioning, you glean what tasks need to be assessed. Or indeed, it's something you can do yourself, and we in LCE will do that regularly with some of our clients, that we'll walk the area, put on an ergonomic hat and help them to identify the higher risk tasks that need to be assessed. Most importantly, consult with employees and their representatives on manual handling risks. And indeed, as you'll see in the H.S.A publication on good practice, a lot of the solutions actually came from those who were carrying out the tasks. Then the next thing you need to do is to complete the first page of the score sheet. So this again is on page 19 of your downloaded guidance document. And so the score sheet, as you'll see here, with the full risk assessment questionnaire that we have looked at a few moments ago. You'll also include details of the site, what items are handled, what's the task involved. So here, of course, capture relevant information, capture information about weights and sizes, capture distances. So that's a critical element of being able to assess the manual handling activity. Also, we need to also identify if there's any indication that the activity, a manual handling task, might be a high risk. So here, again, it's a tick box on your score sheet. So if the task has a history of manual handling incidents, and this is the second place where I said that there would be a reference to UK legislation. So this references RIDDOR, R-I-D-D-O-R. RIDDOR stands for the Reporting of Injuries, Diseases and Dangerous Occurrences. And that's the UK equivalent of our Irish version of reportable accidents. So if you've had reportable accidents, which again, hopefully you're all aware, is any accident that results in somebody being unable to carry out their normal work for more than 3 consecutive shifts, and that becomes reportable to the H.S.A. And that if that's because of manual handling, that's a very good indication that that manual handling task is a high risk. If it's known to be strenuous, if again you see people struggling in workplace, finding it hard work, red-faced, sweating, well, then that's a very good indication that it's a high risk. And also on the score sheet, you also then include details of any psychosocial factors that are brought to your attention. And as I say, we don't rate those when we are doing our assessment, we just record them. So how do we get to the next stage? We've completed our score sheet. Now we need to gather the data and we need to observe the task that we're assessing. Now, if you can video, great video, but please be very conscious of the GDPR situation. Get permission and make sure that when you're capturing video, that you get a representative time of what you're trying to assess. It might seem very basic, but there is a significant skill in recording a task and then being able to download it or look at it at your desk and analyze it to carry out an assessment. And in fact, one of those areas that we focus on when here in LCE we run a certificate in practical ergonomic assessment. We run a 3-day course here, and that's one of the areas that we focus on is ensuring that attendees develop those recording skills. So select the appropriate type of assessment. So then you look and you say, right, is it a lifting, is it a carrying, or is it team handling? And indeed here you may have a situation where the task involves lifting at one stage and then carrying at another stage, in which case you need to do 2 assessments. Then you follow the appropriate assessment guide, and as we go through the guide now, it'll become clearer when you're doing your assessment, you allocate a score and a colour. And we're all used to the green, amber and red in terms of low, medium and high risk. This tool, and indeed the other assessment tools, RAP and ART, introduced this purple risk category, and Frank would have referenced this earlier on. The purple risk category is basically off the Richter scale. So if there's a purple risk, that means you should really, really consider whether you should continue or let someone continue with that task. So as we go through the process flow, we'll identify for each risk factor the level of risk, the colour, and the scoring. But there's guidance, and that's what we do. We follow through the guidance. So let me look at the guidance first off. And there's a score sheet here, but I'm going to skip the score sheet for 1 second. So this is the flowchart for lifting operations. So on your guidance document, it's the one with the blue banner across the top. And the guide, I'm just finding it here, is the flowchart is on page 7 of 20. So on page 7, you have your flowchart. And the flowchart guides you through assessing each risk factor. So for example, we start by assessing the impact of load, weight, and the frequency of the lift on musculoskeletal health. Then we assess the hand distance from the lower back, which is another factor that contributes to musculoskeletal health. We then go to the vertical lift zone. We then go to torso twisting. We follow it up to postural constraints. We go to grip on the load, floor surface, environmental factors, and then we have completed our assessment of the risk factors associated with a lifting task. We then rate each based on the guidance. So I'm going to move down and you'll see. So this is the assessment guide for lifting operations. And so this is our first risk factor. So for this, I'm actually going to ask you to go to that guide, which is on page 3. So on page 3 of your workbooks, here is the assessment guide for assessing the contribution the load, weight, and the frequency of the lift makes to musculoskeletal ill health. And how you use this is that you identify the load, weight that's being lifted. And I think that's one of the things that Emmett mentioned when, in relation to the cladding on the Garda station, was that they actually hadn't started out by doing an assessment where they had an idea of the load weights even. So we need to know the weight of the load that is being lifted. We find that weight on the weight load axis there. And then we go across and we match that up against the frequency of the lift. So let's say, for example, somebody is lifting a 10 kilogram load and they're lifting a 10 kilogram load once per day. So I get my 10 kilograms once per day, that's in the green. Let's say someone is lifting a 10 kilogram load and they're lifting that once every minute. So again, what you'd see here is 10 kilograms on the weight load axis and go across to 1 minute or 60 every hour. And again, you have green 0. So what I'm going to ask you to do is just a very short exercise. And again, don't fill in your answers in the Q&A box or anything like that. But remotely, I'm going to try and get nearly 100 people to participate in a brief exercise. And I'm going to ask you, what color and number would you rate a lift that involves a person carrying 30 kilograms once every 5 minutes, or every 12 times every hour, somebody lifts a 30 kilogram load? So have a look at that chart. And hopefully you have all identified that the color is amber and the score is 4. So amber 4. We now need to put that into our score sheet. So the score sheet I'm going to show you involved a 40 kilogram lift every 5 minutes. So it was in the red. So if I go back to my score sheet, what you'll see here is load, weight, frequency. And in the load, weight, frequency, under the lift column, I have inserted R for a red risk. And then 4 columns over, the numerical score for lift is 6. So that's again, comes straight from our guidance. We're going to now look at the hand distance from the lower back. So the hand distance from the lower back, we're going to look at that guidance document and identify what color and what score we're going to give it. And we're going to fill those in on the lift column. If you're doing an assessment of the carrying, you would look at the carrying column under color and the carrying column under score, etc. So we now look at hand distance from the lower back. And one of the fabulous things about these assessment tools is they contain great graphics. So literally what you're looking at here is, where is the upper arm relevant to the upper torso? So as you'll see in the first part there, or the first graphic, it's a blue upper arm in line with the torso. If the lift can be carried out like that, well then we scored a G for green and a 0 for a number. If the upper arms are angled away from the torso, or the torso is bent forward, we give it an amber 3, and it's a red 6 if the arms are fully outstretched, and the arms are angled away from the torso and the torso is bent. So again, we fill that in on our score sheet. We now look at the vertical lift zones. So here we're looking at the range from below floor level up to above head height that someone has to lift the load. Now, what you see here is we're literally looking at each individual risk factor separately. So we've already looked at how far away from the lower back someone is lifting something. Now we're looking at, do they have to lift it from below knee height or further? So we observe the vertical position of the worker's hands at both the start and the end of the lift. So if generally the hands are between the knee and elbow, we give it a green and a 0. If the hands are between knee and floor level or elbow height and head height, we give it an amber 1. And at floor level or below, or at head height or above, we give it a red 3. Now, some of you at this stage will have noticed that in the previous risk factor, the red was up as far as a 6, and here the red only equals a 3. And the way this tool is designed is that the contribution each risk factor makes to the potential for injury is weighted. So in the previous example, the hand distance from the lower back, the further you carry something away from your lower back, the greater the risk of a back injury or musculoskeletal injury. So therefore, that's weighted as a 6. Whereas, although the vertical lift region can result in back problems, it's not as heavily weighted as the distance you are from your lower back. The other thing that I just want to highlight on this one is that, let's say, for example, someone is lifting from a pallet. Okay, so let's get to think about this for a second. So you're lifting from a pallet, the last layer of boxes on a pallet or delivery on a pallet. Where would you rate that? So just have to think about it for a second. Would you do amber 1 or red 3? Now, the mistake that a lot of people make is that they jump to red 3. The answer, in fact, is amber 1. And the reason that it's amber 1 is that a pallet isn't on the floor. A pallet is raised, whatever it is, 300 mil or so from the, sorry, not that high, 150 mil or so from the floor. So a pallet is actually, lifting for a pallet is an amber 1. So now we're going on to the next risk factor on our flow chart. And now we're looking at the torso twisting and sideways bending. So here, again, you're looking at the graphic and you're looking at the person carrying out the lift. And if there's little or no torso twisting, green 0. Torso is twisted, slightly be more than neutral. So a little twisting beyond the neutral zone is actually okay. That's a green 0. But if the torso is twisted or sideways bent, it's an amber 1. And if it's both, it's a red 2. Hopefully you're all getting the picture of how easy it is to use this tool and to understand the graphics. Now we look at postural constraints. So we're on to E in our flow chart. And we look for factors that force the workers to modify their posture. So if their movements are restricted when lifting, so lifting in a narrow aisle or in a crowded or disorganized storage space or lifting through narrow gaps, well then the color band is amber. And if the posture is severely restricted, then we give it a red and a 3. Then we look at the grip. So again, here you're looking at whether somebody has been able to lift something that has a fit for purpose handles or a cylindrical handle, we give it a green 0. If it's your poorly designed handles or it's your standard grip that you'd have when you're been trained on how to lift a box of photocopier paper, that's an amber 1. Or if it's poor grip, as displayed by the graphics there, we give it a red 2. Now we look at the floor surface. So we look at the condition of the floor. If it's clean and dry and firm and undamaged, green 0. Otherwise, it's mostly dry and clean with some debris, we give it a number 1. But if it's slippery, we give it a red 2. And the rating again here, the red being a 2, is the contribution a slippery floor will make to the potential for a musculoskeletal injury. And then we look at our environmental factors. So here we look at if there are extremes of temperature or strong air movements or strong extremes of lighting. and depending on the number of environmental factors that are present, that will dictate whether we score a green 0, an amber 1, or a red 2. So that was a brief overview of the going through the flow chart. So now what I'm going to ask you to do is, in a great exercise is getting nearly 100 people to complete an assessment. I'm going to show you a video, and I'm going to ask you to make an attempt at completing the score sheet for this lifting activity. So I'm going to ask you to go to the final page of that download, which is page 20. On page 20, you'll have the score sheet, and each risk factor is on the left-hand side, or the first column, and then, as shown earlier on, you have the second column is where you score or you put in the colour band for the lift, or the numerical score then goes into the fifth column. Now, for those in the construction industry, I know you're going to see this video and you're going to think, oh, sure, that's fairly simple, that's fine for other industries. You're not going to be lifts like that on construction sites. This is only to give you a feel for the tool. So it is a very simple lifting boxes from a pallet onto a conveyor, and it'll give you a flavour of how the scoring happens. What you'll see is also with this video is that the video plays through 3 times. And the reason that it plays through 3 times, very difficult to say, but the teeth back in there, is that you really need to observe 3 kind of cycles of a particular activity to get a good understanding of the postures, the forces, the frequency of lifts. So without further ado, I am going to ask you, if you wouldn't mind, please, to show the first video. And I'm going to ask you all then to have a look at this video, and as we go through it, start to score on your score sheet how you would rate each risk factor. So thank you very much. Okay, so the video does play 3 times. You've now got an idea of the weight. We now get the frequency of the lift. Okay, so this is our final version now for you to just double check your scoring. Excellent. Okay. So thank you very much for that, Emmett. I beg your pardon for you. So we're now going to let you compare your scores to the scores that the H.S.A have given this. So these are the expert scores. So let me go down here. So the load weight frequency, or 6, hand distance, or 6, vertical lift, A2, trunk twisting sideways bending, or 2, posture constraints, A1, grip on load, A1, floor surface green, 0, and other environmental factors, none. So if you want to get practice in, because this is only obviously an introduction to the tools, and certainly not designed to make you an expert, but should give you enough confidence to give it a go. But there is more practice exercises that you can follow through with the H.S.A on the H.S.A's website. So now with that scoring, I'm going to hop back to the slide a few moments ago. So I just want to explain the score sheet. So on the score sheet, we obviously have given each risk factor a number as well, and we can get a total overall score. Now, those of us in health and safety are so used to having an overall score, having a meaning in relation to the level of risk. This is slightly different. With the MAC tool, the overall total score actually gives no indication as to the overall relative risk for a particular task. All that the total score allows us to do is to prioritize which task we should address first. But the 13, 17, and 9 doesn't mean that the lift is the carry is a higher risk than the lift. Because each individual risk factor in its own can contribute to a musculoskeletal injury. So it's not a cumulative effect as we would normally be used to in risk assessment. Now, so that doesn't happen with the MAC tool. So there you'd look and say, right, we have the red in the load weight frequency for a lift. That's what we need to address, regardless of the fact that it's a 13 in the overall score. So there is also a lift guide then a guide, I should say, not for a lift, but a carry operations. So it's the same. We're not going to go through this again, it's just to introduce you to it. There's a carry operations assessment guide. That's the orange banner across the top of the pages. And again, you look at individual risk factors. But for the carry operation, there's a slight difference. There's a difference in the assessment guide for frequency and weight. And so this looks different to the load weight frequency chart that you have for lifting. And hand distance from the lower back is the same. We then introduce this asymmetrical torso or load. So we assess where are we carrying the object relevant to our upper torso, and we score accordingly. Postural constraints, the same. Grip on load is the same. Floor surface is the same, but now we introduce carry distance as a risk factor. So we assess whether or not the distance is between 2 and 4 meters, 4 to 10 meters, or over 10 meters. And here again, you're not expected to get out a measuring tape and lay it down on the floor to see if it's 10 meters or over. An estimate is more than adequate. A large step or stepping it out is more than adequate here. Obstacles en route, again, that's another different risk factor in relation to the carrying task. So here we look at the number of obstacles, the number of type of obstacles that may be en route, and we rate accordingly. And then we look at the environmental factors, which again are the same as for a lift. This is a video again from the H.S.A's website, linked from the H.S.A, that you can again carry out your own assessment and compare your results to the experts. So this is a carrying task in a pastry factory. It's a very good example because it's about carrying things up and down steps. So it would be very applicable to the construction industry. And again, what you will do is you will get the scoring, and you can compare your scores to the scorings of the expert. But we are going to get you to do a little bit more work before we finish, because now we're going to look at a team lift. So this is where you go to the dark green on your workbook, so the dark green banner, which is your team handling operation, and that is on page 13 of 20. So I'm going to ask you to go to page 13, and we will briefly walk you through the various risk factors. So here for load weight, we don't have a graph. For a team lift, we look at the number of people carrying and the weight that they are carrying. So, for example, I'm going to go back to Emmett's situation where there were 2 people lifting trying to lift 142.5 kgs. Actually, I think there was probably more than 2. So, if the load weight was 142.5 kgs and 4 people were lifting it, what score and colour would you give that team handling in terms of the load weight risk? So we're looking at 4 people carrying 142.5 kgs, and hopefully all of you have seen that falls under red and 6. So even with 4 people carrying that cladding, it was still a high risk in terms of the weight of the load. The next thing we look at is the hand distance from the lower back. So here it's the same criteria as for lift and carrying. However, what we look at here is when it's a team handling operation, we look at the worst case scenario. So if you have someone with extremely tall stature or broader and someone with extremely small stature, one has their arms well away from their upper torso and the other doesn't, well then you take the assessment on the basis of the person who's got the arms furthest away from their upper torso. Similarly with the vertical lift zones, same criteria. Torso twisting and sideways bending, again we look at the worst case of the individuals who are carrying out the team lift. Postural constraints, same thing. Grip on the load, same criteria again. Floor surface, again that's similar criteria as for the carrying task. Carry distance, similar criteria again in terms of the carrying task for a team handling operation. Obstacles en route, again similar. But here we have a new risk factor, and the next risk factor we need to include for a team lift is of course communication, coordination and control. So we really need to look at, is there someone controlling the lift in the team? Is one person starting off before everybody else, forcing one member of the team to support a greater load for a short duration? So, and again, we're going to show you a short video and you're going to get an opportunity to rate this. Then you look at the environmental factors. Again, same criteria as for the other 2 guides. And we'll move down here. So we're going to give you a chance to do it again for you. This is again about a 4 or 5 minute video. So if I could ask Hugh to get that set up for me. And I'm going to ask you again on your same score sheet, but this time we're going to fill the columns for a team lift. So if you go to your score sheet at the end of your publication, and that again is on page 20. And I'm going to ask you to look at this video. Again, it plays a couple of times. It's 3-4 minutes. And look and score the team lift based on the process flow and each risk factor for a team lift. So if you wouldn't mind, Hugh, throwing that on for us there, it would be great. Now, what you see with this training video is that they'll actually slow it down and you'll see it in slow motion so you can actually see more detail in relation to each risk factor. And one final view of it all. So finish off your scoring now. Excellent. So thank you very much, Hugh. We'll now just give everyone an opportunity to check how they scored versus the experts in the health safety executive. So we have a load weight or 6, green 0 for hand distance from lower back, A1 for vertical lift zones, A1 for torso twisting, sideways bending, green 0 for postural constraints, grip on load A2, floor surface or 3, carry distance A1, obstacles on route 0, green 0, communication red 3, and environmental factors none. So hopefully you'll have trialed that out and your scores should be in and around that. But if you want more practice, there's more available on the Health and Safety Executive's website. So in terms of manual handling, firstly, you should ask yourself, does the manual handling task need assessment? Not all manual handling tasks on a construction site need an assessment. So we need to look at the activities that, by the very nature of the environmental conditions, that present a risk. Then identify whether or not a full risk assessment is required. So go through your conditions criteria on your score sheet. Then decide if MAC is suitable, or should you potentially be using an ART or a RAP. And then identify which of the assessment tools, whether it's lift or a carry or a team lift, and if more than one assessment is required, whether if it's a lifting and carrying in the same task. And of course, be very much aware that if there are a variety of weights being carried throughout the day, there is the MAC tool can be used, but it can be used in conjunction with what's called the VMAC. And the VMAC, very briefly, is the varied MAC assessment, and that's available on the H.S.A's website, where you just input the size of the weight of the lift and the frequency, and you can do a combined assessment for a variety of lifting, normally in a distribution centre, that you can get an overall risk categorization for that one. So just before I go in relation to the system, as you've seen, at the moment it's a paper-based system. The H.S.A are developing an app that will assist you to carry out the assessments. And just for information purposes, from the use of a handheld device or a tablet, LCE, we've developed an Easy Ergo tool as well. So if anyone would like any information on the Easy Ergo tool, please feel free to do so. And just before I hand back then to John, one other question that keeps popping up in relation to these workshops is this now making you competent to carry out an assessment? Well, competence is defined as training, experience, and knowledge. So you really need to develop your experience and your knowledge of the tools. And to take a little bit of poetic license here, just for anybody who may be interested, we here in LCE run a certificate in ergonomic assessment, practical ergonomic assessment course. It's a 3-day course where we develop people's skills in using the H.S.A suite of tools, MAC, ART, and RAP, and including the video skills. So it's a blended learning course. Our next course is actually running in November, and November 16th it's commencing. So it's primarily a blended learning, so there's remote and self-directed learning as well, starting in November. So if anyone would like any more information, I believe there are places left, please contact info@lce.ie. And I should also emphasize, because I'm saying this at a H.S.A workshop, that the H.S.A have not rubber stamped LCE's course or anything like that. It's just that we produced this course, and the information is available there if you need any further detail. I'll hand back to John. Thanks a million.
Yeah, I guess on my part, I have some more homework to do. My scores didn't entirely match that of the experts, so more work to do on my part. Just the Isa referred to the Easy Erg app, or tablet app, and I was fortunate enough to receive a demonstration from Isa, and I found it very intuitive, easy to follow, so it's technically a really useful tool to have. So at this point, I'd like to ask all of the today's lecturers if they wouldn't mind enabling their video, and we'll have a try to address some of the questions raised. Okay, so the first question that came through is, and it's directed at Frank, and the question is, are there any case studies of the use of the MAP and RAP tools in the Irish construction industry?
Thanks for that question. We've come across a couple of examples on sites where efforts have been made to use the risk assessment tools, i.e. the MAC tool and the RAP tool. However, we want to see a lot more of that. We want to see a lot more use of these risk assessment tools. And that's why we have been doing these workshops and webinars so that we can influence the quality of risk assessments related to manual handling tasks in construction, so that we see a lot more of this. The work that Emmett did, the case study, again, that's another way of getting the message out there of how important the risk assessment process is. So those good practice case studies as well are another example of how we disseminate that message. So thanks for the question.
Right, and a detailed question, and maybe best thing that Eva. So what level of training does an instructor for using an EVAC chair need? As general application regulations don't say if the standard manual handling instructor training is sufficient, or if patient handling manual handling instructor is required, as the definition of manual handling covers both.
Oh, I'll take it. So in relation to the use of an EVAC chair, again, it comes down to the competence side of things. So specifically, it's not considered the patient handling perspective unless you're assisting a patient getting into the EVAC chair, but purely using an evacuation chair, evacuating somebody from a building down a stairs once they're already in the chair. Again, the level of training is based on the individual's competence, either from the suppliers perhaps, but the patient handling training is not required for an EVAC chair. If, however, as I say, you are putting someone into the chair, then patient handling, that would come under the patient handling banner.
Thank you. Next question is to Frank, and it's as follows: would the manual handling solution in the example need to be CE marked for use in the workplace?
Again, thank you for that question, John. In relation to solutions for, I suppose, manual handling issues in construction, we would expect that the PSDS or else the PSTP or the designer would take account of the use of work equipment regulations in the Safety, Health and Work Act, Work General Application Regulations 2007. So things like lifting gear, chains, and other associated equipment would have to have certification for safe use, certificate of conformity, and take account of the machinery directive in that regard. Another important point related to use of solutions and development of solutions for manual handling issues in construction is that a risk assessment should take place to take account of the use of this piece of equipment. Because what you don't want to do is, by using or introducing an intervention to address one problem, that you create another problem. So it's important that process takes place as well, so that everybody is on the same wavelength and on the same page in terms of the use of equipment in a safe manner. Thank you for that.
Thanks, Frank. And next question is as to whether all of the slides are available after the session. So I might just start that, and Frank, you might just jump in if I miss anything.
Yeah, we don't normally provide the slides, the slides for the presentations now. Primarily, the main slides would be Ita's, right, and the presentation that Ita gave is primarily what's in the Mac tool. It's all the information from the Mac tool. So we would just, I suppose, direct people to refer to the Mac tool documentation and our actual documentation. With respect to my own presentation, I mean, this came up last week. If some people would like to get a copy of my presentation, they can email me at _power@hsa.ie, and I have no problem sending on a copy of the presentation. But the major significant work, I think, we would just refer you to the Mac tool. I can't comment for Amish, but if Amish wants to do the same, that's feel free to do it. But as a matter of course, we don't normally send out all the slides. So thanks.
Thanks, Frank. And it says, should the design team not have picked up on the weight and the methods for lifting operations for the stone cladding? And was there a breakdown of communications between designers and the PSDP during the design process?
Well, I suppose there certainly wouldn't have been a breakdown in communication between the designers and the PSDP, as the architect was the PSDP. So, but with regard to it, there was no design risk assessment relating to the stone cladding specifically. And they didn't pick up anything on the weights. To be honest, they were fairly insistent that the stone had to be the size that they were. And I know there's another question coming, and I'll deal with that in a few minutes on that. But just in terms of, I suppose the answer that we got back, in a sense, was, well, you did it right eventually. Why didn't we do it right to start with? So, to be honest, the designers and the PSDP put it back on us as contractors as to why you didn't do that risk assessment initially, to be quite honest. You know, it's not the right answer from them, but that was what we were hearing at the time.
Thanks, and just following on from that, I guess the question there is, was there a H.S.A advice note report inspection for the designers also, or was it just for the contractor following inspection? No, so there was a separate, there was actually 3 reports of inspections issued on the back of this. So one was to us as the PSCS, one was to the stone cladding contractor, he received one also, and the architects, which was, they received it. I actually have it in front of me here, and it asked for them to take account of the regulations in relation to the need to manage risks relating to manual handling. And also they had to provide evidence to the requirement that the stone thickness must be 75 mil. Now, I don't actually have any record of the response back to it, but they were able to issue specification in terms of weathering as to the reason why they were trying to go with 75 mil. On this case, anyway. I know we have got it reduced on current projects that we're at, where again, we've learned the lessons from this. We've engaged very early. We've reduced sizes, both in thickness and in length and height, on current projects, especially ones where we're involved as design and build contractors. It's a lot easier, obviously. But in terms of this, they did get notification or a report of inspection, and they would have had to respond to that also. Thanks, Emmett. And following on, I guess it's Emmett, for each director at you, as to whether a temporary work design chart is required for the fabricated attachment. So the correct answer to that is yes. Again, I'll put up my hands on this. In terms of that job, we didn't complete temporary works design certs. We have done it since, and we have done the temporary works design certs and gone through that process. But it was probably something that we overlooked or didn't include within the process, but we picked it up after that, and the next project, yes, we implemented temporary works designs, risk assessments and designs as part of that. Thanks for that, Emmett. And just to mention, the whole area of temporary works design, it's a complex area, so it's not an easy apparent as to what is and what isn't. And within the CIF, we've had a working group for some 7 years now, trying to finalise a guidance document. And it's always around the British standard 5975. So it is something that we're hoping to release in the next few weeks. Obviously, the British standard is there, it's acknowledged. It's done by the H.S.A and the Code of Practice for Access and Working Scaffolds, and we'd like to provide additional guidance around that. Next question is in at Frank, and it's, is it possible to use the map tool as part of a design stage risk assessment process?
Yeah, thank you, John. Yes, absolutely. I think this is where we'd like to go with this as well, is apart from people like Emmett and contractors using these risk assessment tools, we would like to see these risk assessment tools being used by designers at that stage in terms of planning out a project, the specifications, the bills of materials and that. So we are engaged, and we will be engaging with design organizations over the next 12 to 18 months as well as part of the work we're doing in the construction sector, so that we can get more information out there around these risk assessment tools. I know when I was on site in Ratkin and Galway and other sites around the country where we were following up on manual handling issues in construction, that I asked to meet with the PSTP on site and the designers to find out what they had done or what documentation they had. But I also asked them had they considered the manual handling risks, and were they aware that there were risk assessment tools available. In most situations they were not. So there's a body of work to be done there, increasing awareness and education around the use of these risk assessment tools and developing guidance so that they can be used appropriately at a design stage in design risk assessments. Because I think in a lot of situations, design takes a good account of safety issues, but health issues, I don't think so. We need to do a lot more in that regard. So, thank you.
Brian Kerr from General Roll. The next question is for you again. What's the first thing that a PSCS could do to improve manual handling risks and manage on site?
Yeah, well, I mean, I'm sure I might have your own views, but I'll just say that, I think one of the key things to do is if you're serious about addressing these manual handling issues on a construction project, that there should be a consultation process between the PSCS and the contractors, because that is something that's incorporated into the construction regulations, the importance of consultation and involvement between PSCP, PSCS contractors. I think it would be a useful process to do at the start of a project to identify, I suppose, the main contractors that are going to be involved in the project, to take account of the main, I suppose, installation projects that will form part of the stages of the project, and then to consider the different range of loads that may be installed on site and get information on the load weight specifications, get information on what the proposed system of work is, and then to flag any potential planned systems of work or method statements as to whether or not there could be potential significant manual handling issues. And then from there, then from that stage, then to go into a risk assessment process for those specific activities or installations to see can we quantify the risks and can we come up with a better way of doing it. That would be my consideration. I'd be interested in what Emmett might think.
Yeah, no, and we would on site. I suppose one of the big things on the back of this would be it's probably a little bit down the stage. It's not at design stage or right at the beginning of the job. But one thing that we would have is that we've built it into our RAMS review or method statement review document, so that when we get a method statement in, there is a specific element within that review. Has manual handling been assessed? Is there a specific risk assessment associated with the manual handling? And then we take it from there. So that's or it doesn't meet our requirements, there's a back and over with the contractor to get it up to the standard where we need it. So that's where we're at the moment for kind of all method statements. And I suppose we have focused in on glazing and stone cladding in terms of, and again, against the case study of ours. And there's another glazing case study that's on the CIA or the H.S.A website. So we're going on that in terms of suckers and lifting equipment and that kind of stuff. So, but certainly it's included in our review of all our RAMs, and it has to be dealt with then. Thanks.
Okay, next question is for Ita. Is a manual handling risk assessment required for all manual handling tasks that take place on a construction site?
Manual handling assessments are not required for every manual handling task. We have to look at the environment in which the task is being carried out and the nature of the manual handling task. And if they indicate that there's a risk, then an assessment needs to be carried out.
Perfect. Next question is directed at Frank. Will there be a recording of this webinar available on the H.S.A website?
We'll be recording. There was a recording carried out for last Thursdays, and there will be one for today. So my colleague Hugh and our IT department will be working on making those available in the next week or two. So they will be available for people to download on our website very soon. Thank you.
The next question is directed at Isa. Just wondering if the H.S.A UK are developing an app for the map and the RAP tools.
Yes, absolutely. They are developing an app which can be used on the hook for assessments. So it's not available as of yet, but I believe it'll be kind of a once-off assessment. It'll be free for some individuals, and then if you want to do quite a significant number of assessments, there will be an associated charge with that.
Super. Well, that's the extent of the questions that come in as yet. There is a question there around temporary works, and I guess it's just to provide an answer to all on that. Does anyone have any further questions? We might just give it a moment or two. And I guess just while we're waiting, so please feel free to use the Q&A function. On behalf of the CIF, I'd very much like to thank Frank, Hugh Jordan, and all of the colleagues in H.S.A for facilitating today's webinar. Additionally, all of today's speakers, Emmett, Leonard, and Isa. I certainly found it very informative. I hope you did too. And lastly, I'd like to thank all of the participants and for some really good questions that were flagged as well. So just going to check last, have we any further questions? And we don't. So to that, I might just hand you over to Frank.
Yeah, not much more to add, really, John. You've thanked everybody there. We appreciate everybody who attended today and also attended the other webinars. So, look, I just want to wish everybody to keep safe and well, and keep an eye on our website, keep an eye on our events. We will be doing more events in 2021, and hopefully we will get the chance to see people where we might be able to do some workshops next year. But in the meantime, look after yourselves, and I'd just like to thank my own colleagues in the Health and Safety Authority, Hugh Jordan, who did a lot of work, background work in setting up these webinars. We've never done this before, so it's a new venture, and my other colleagues, Barry and Simone. So thank you very much, everybody, and I'll hand over to you, John, maybe to close out the webinar. Thanks to Isa and Emmett as well.
So we'll wrap it up there, and a sincere thank you to all, and stay safe, and we'll see you again soon.